Okay, so here we go with the second part of the law of sines or sine law, and this is an ambiguous case idea. Okay, now ambiguity, that word itself, if you look it up in the dictionary, it refers to there not being an exact choice. It could be one thing or the other. You're not quite sure. It's ambiguous. Now, that happens when we have what we call an ASS triangle. I've referred to them as an SSA triangle. The reason is obvious, okay? Because this is a pain in the ass, all right? Now, what that means is that if you're given an angle, say, of let's go 30 degrees, okay? And you're given a side of, say, let's say 10, and then another side over here of, say, 7, okay? Now, the ambiguous part is, right, you don't know anything else about this situation. You know that you have an angle and two sides. But what you don't know is exactly where this side is. Where else could this side be in this situation if this is the only angle you know? Okay, now be in mind that you don't know this angle. It could be big, it could be small, right? You don't know these angles either. So what I'm hoping that you can see is that you create a situation where there's two possible solutions, right? It could be this 7 or this 7, and what you don't know is which one is it. And what arises here too is that there are certain situations where you have two possible solutions. Okay, so you're going to be asked how many possible triangles are there. Well, in this case, there's two possible triangles. In some cases, there will be just one triangle, and in some cases, there will be no triangles. Now, what is the deciding factor in this situation? Well, if you looked at this situation again, okay, where this is 30 degrees, all right, this is 10, and this is all we got. This is all I got. Now, what is the shortest side that I could put here that would close this off and make it a triangle? Well, I hope you can see that it would just be a vertical line, right? A vertical line where this is your height. Now what you got to do is you got to figure out what that height would be. So in this case, if you went sine 30 is equal to h over 10, you'd find out that h is 5. Okay? H is 5. So in this situation right here, okay, if your h was equal to 5, then you have one triangle. You'd only have one triangle. Okay, now that means that it would have to be a right angle triangle because it's the shortest side, right? Now, what happens if h was less than 5? Right? If this side was shorter than 5, it would never actually reach the bottom. Okay? It would look like this. It'd be hanging here and it'd be swinging back and forth. It wouldn't be long enough to close off that triangle. So I call that a dangler. Okay? So you have to find that minimum length first, always. What is the shortest length that could be? If it was 5, then you tell me it's a right angle triangle. If it's shorter than 5, you tell me that you have no triangles. There are no triangles possible, okay? I call that a dangler, okay? And what about if h was greater than 5, right? Well, if h was greater than 5, then you have a situation like this. You can squeeze it in either on this side or you can squeeze it, lay it out on that side. So if h is greater than 5, then you have two triangles, right? Now there's a certain point again beyond which you only have one triangle, and that's a little bit different. I'll explain that to you I'll explain that one to you. This h can keep getting bigger and bigger. We got a 7 here, we can get 9, but you see that as soon as you get 10, you can't really go in there, so you have to go out here now. And anything greater than 10, boom, 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 ends up being just one triangle again. So we can simplify this and say if h is between 5 and 10, and if h is greater than 10, then you have, again, just one triangle, and it's going to be what we call an oblique triangle. Okay? This is the basic idea of what we call the ambiguous case. what I can do is just write down a couple quick points for you, okay? So here we go. The ambiguous case, all right? It occurs when we have an ASS triangle, okay? When we have an AAS triangle, the first thing that you have to do is find the minimum height to create a triangle, okay? Find the minimum height to create a triangle. That would be this step right here, finding out that H, okay? And we'll call that H, okay? So if the given side is less than H, there is no triangle, okay? We call that the dangler. And if the given side is greater than H, then we have, or sorry, if it's equal to H, then we have one triangle, okay? If it's equal to H, we have one triangle, and it is a right angle triangle. And if it is greater than H, then we have two triangles, okay? If this diagram here that we did makes sense to you, great. I'm having a hard time maybe summarizing all these notes, but hopefully you're getting the idea as to what it is you need to do, okay? So let's look at a situation here. If in triangle ABC, okay, angle A is equal to 42 degrees, all right? We have side B is equal to 15, and we have A is equal to, let's have a look here. Well, let's leave that one alone for now, okay? Because what we're going to do here every time, guys, is you're going to generate a triangle. Okay, you got to draw this situation. So we start off with the base. Boom, always put the base. Angle, right here, angle, 42 degrees, okay? And the side that you're given, we should put up here, angle A, whatever it is, we'll fill that in a sec, okay? So this is what we need to do. We need to figure out what this minimum height is, okay? Angle B is down here somewhere. We don't know where, okay? But what we're going to do is we're going to find this H right away. And that would be sine 42 is equal to H over 15. So H would be, let's check it out here, sine 42 times 15, we get 10. Okay, so H is 10, let's call it. So my minimum height here is 10. So look at this. If A was less than 10, there is no triangle. Okay, it would be that dangler situation where you'd have it sitting there hanging and it wouldn't be able to close off that triangle. Okay, now if A was equal to 10, okay, then we have a situation where you have one triangle, okay, and it is a right angle triangle. Okay, it's a right angle triangle. If A was greater than 10, but A was also less than 15, right? We can write it like this. Then we have two triangles because this is where you're squeezing it in, right? 11, 11, 12, 12, 13, 13, 14, 15, whatever. And then if A was greater than 15, you again have one triangle, right? And it would be an oblique one because it wouldn't fit under here anymore, so you'd have to go out to this side and make it nice and big. All right? So that's the type of question you're going to get. You're going to get an A value, okay? I didn't give you one here. I just showed you the different situations that you're going to have.